Hi students. Okay, today we are learning the topic is Cauchy-Euler equation. So, what is the definition of Cauchy-Euler equation and how to finding the general solution of the Cauchy-Euler equation? So, we are learning in this lecture. Okay, see the first of all definition is an equation of the form x power n into d power ny by dx power n plus pn in p1 into x power n minus 1 into d power n minus 1 y by dx power n minus 1 plus up to so on pn minus 1 x into dy by dx plus pny is equal to q of x, where p1 p2 up to so on pn are real constants and q of x is continuous function of x is called Cauchy-Euler differential equation of order n. So observing here in the previous lecture, higher order differential equation with constant coefficients. So now here some variable coefficients and x children dy by dx coefficient x term, but here order is equal to the x power. This is the nth order, this is the x power n. So d power n minus 1 order x power n minus 1 and must be equal. The order x power must be equal. So this type of equation is called Cauchy-Euler equation. This is nth order, so that is called nth order Cauchy-Euler differential equation. So now write the operator form is. So operator form is, see that x power and d power n plus p1 into x power n minus 1 d power n minus 1 plus p2 into x power n minus 2 into d power n minus 2 plus up to so on pn minus 1 xd plus pn into y is equal to q of x, where d is equal to d by dx. This is the operator form of the Cauchy-Euler equation. ఇక్కడ చూడండి d power x power must be same compulsory. So all are same and so this is called Cauchy equation. So solution, how to finding this solution? So in the previous lecture we have to finding the solution of the given only solution with the higher order differential equation with the constant coefficients. So now and also this equation is converted to only a differential equation with the constant coefficients, and now eliminating x. Totally x eliminated will be eliminated by x, then after converted a differential equation with constant coefficient, then now finding the solution of that equation. Okay now, so how to eliminating x here? So that is the given equation reduced to a differential equation with the constant coefficients by substitute a suitable function x is equal to e power z, and x place lo e power z replace cheyandi, or log x is equal to z, a new variable here. Then we have, so after substitution we getting xd is equal to theta. Theta is also another operator. So theta is operator, differential operator with the new variable z. D is a differential operator with the respect to x. So theta is a new operator with the new variable z. So xd is equal to theta, substitute. Next one, x square d square is equal to theta into theta minus 1, and x cube into d cube is equal to theta into theta minus 1 theta minus 2 up to so on. And so x power d power same, theta into theta minus 1 into theta minus 2 into theta minus 3 up to so on. All are substituting in the above equation. We getting a new equation that is with constant coefficients only. Now solving that equation, the solution in terms of z. After finding the solution, now replacing z. Z is equal to log x replacing, or e power z is equal to x replacing. So this is a Cauchy-Euler equation and solution of Cauchy equation. Okay. Now we have to see that the example. See the first example here. X square d square y by dx square minus 2x into dy by dx minus 4y is equal to x power 4. So write the first operator form. So this operator form x square, this is d square minus 2xd minus 4 into y is equal to x power 4. So observing here, which is clearly Cauchy-Euler equation. Chudandi, this is x square d square, x d constant. So this is second order Cauchy-Euler equation. So in this equation, substituting the same procedure to every problem same, x is equal to e power z, then log x is equal to z. So then we have the formulas up to second order, ante xd and x square d square. We have to formula here. Then we have xd is equal to theta, where d is equal to d by dx, theta is equal to d by dz. So x square d square is equal to theta into theta minus 1. Substitute in equation 1. From equation 1, theta into theta minus 1 minus 2 theta minus 4 into y. So x power 4, x is equal to e power z whole power 4. So that is simplification, theta square minus 3 theta minus 4 into y is equal to e power 4z. So this is a new differential equation with the constant coefficients. Chudandi, x is eliminated. So in theta is a new operator. That is equal to f of theta into y is equal to q of z, where theta is equal to d by dz. Same procedure. Now finding here non-homogeneous, the solution is y in terms of z. So first finding the auxiliary equation, now finding the complementary function. That is equal to here f of theta is equal to here and q of z is equal to e power 4z. So auxiliary equation is f of m is equal to 0, అంటే theta place లో m replacing, అక్కడ d place లో m కదా, here theta place లో replacing theta by m square minus 3m minus 4 is equal to 0. So that is equal to, take the factorization, the roots is m is equal to minus 1 comma 4. So minus 1 comma 4 is a real and distinct. So therefore complementary function yc is equal to c1 into e power minus z plus c2 into e power 4z, and a solution in terms of z. Here independent variable z, so solution in terms of z. So now finding the particular integral. So particular integral is equal to 1 by f of theta into q of z. So that is equal to 1 by f of theta is equal to theta square minus 3 theta minus 4 e power 4z. So this is the type 1 here. 1 by f of into e power ax, a is equal to 4. Now take the factorization, theta plus 1 theta minus 4 into e power 4z. Here a is equal to 4 here, theta plus లో 4 replacing. Using type 1, here a is equal to 4. So first one theta plus 1 ante 4 plus 1 non-zero. Second one is 0. 4 minus 4 0 kada, 1 time 0. That is equal to 1 by 4 plus 1. 1 time 0 got z power 1 by 1 factorial into e power 4z. That is equal to z by 5 e power 4z. So therefore general solution of equation 1 is y is equal to yc plus yp, adding both c1 e power minus z plus c2 e power 4z plus yp z by 5 e power 4z. But this is a solution of assumption equation, but given equation is in terms of x here. So now replacing here same, c1 into e power minus z means e power z is equal to x, that is x power minus 1 plus c2 into e power 4z means e power z whole power 4, that is x power 4. Z is equal to log x by 5, e power 4z means x power 4. So this is the final solution of the given equation. Okay, see the next example here. See the second example here. So this is the given equation. So take the operator form, x square dq plus 3x d square plus d into y is equal to x square log x. So now observing here which is Cauchy or not. So here x square d cube, you can change x power 2 or d power 3, but not same. But here x d square d, but there is no x. So one x power missing, and so 1 power x power is missing. So now converted to Cauchy's form, that is multiplying with x on both sides. Now multiplying with x on both sides, that is equal to, so now multiplying by x, x cube d cube plus 3x square d square plus xd into y is equal to, here x square means x cube log x. Okay, now this is the now Cauchy-Euler equation. So now substituting in the equation, x is equal to e power z, z is equal to log x. Then we have, this is third order equation, xd is equal to theta, x square d square is equal to theta into theta minus 1, x cube d cube is equal to theta into theta minus 1, theta minus 2. Substituting equation 2, from equation 2, these all are substitute, and x cube is equal to e power 3z log x is equal to z. Simplification is theta cube into y is equal to e power 3z z. This is f of theta into y is equal to q of z. Now finding the solution is non-homogeneous yc plus yp. First of all, finding the complementary function. So this is one. xd equation m cube is equal to 0. M cube is equal to 0 means m is equal to 3 times zeros, 3 equal roots. No, no? 0 comma 0 comma 0. So yc is equal to c1 plus c2z plus c3 z square. And particular integral 1 by f of theta into q of z. So that is equal to f of theta is equal to theta cube 1 by theta cube into e power 3z into z. Which form here? Type 4 kada. 1 by f of d into e power ax into v form. E power ax, a is equal to 3. So in the theta replacing theta by theta plus 3. That is equal to e power 3z by 1 by theta plus 3 whole cube z. Again using here which form here? 1 by f of d into x kada. Type 3. That is z power k here, x power k here. So that is equal to theta plus 3 can be right. Lowest degree term 1 plus f of theta kada. So lowest degree 3 common, e power 3z by 1 by 3 cube by 1 plus theta by 3 whole cube. So that is equal to e power 3z by 27 into 1 plus theta by 3 whole power minus 3, write the numerator, into z. Which form here? 1 plus x power minus 3 form. So 1 plus x whole power minus 3 expand by using binomial theorem. So 1 plus x whole power minus 3 using this formula, 1 minus 3x plus 6x square minus up to so on. Here x is equal to theta by 3. That is e power 3z by 27 into 1 minus 3 into theta by 3 plus 6 into theta square by 9. But up to expand only z power 1 and theta power 1 only expand. Only constant theta. Theta square, theta gives all are eliminating 0. So that is equal to continuation is so e power 3z by 27 1 minus theta plus 2 by 3 theta square minus up to so on into z. So simplification is multiply with z minus theta z. So that is equal to e power 3z by 27 z minus theta z means theta is equal to d by dz. Derivative of z is 1. So this is a yp and therefore general solution yc plus yp. So this is a yc plus yp. After replacing z by log x, e power z by x, that is equal to, after simplification is c1 plus c2 log x plus c3 log x whole square plus x cube by 27 into log x minus 1. So this is the solution of the given equation. So next example here. So solve x cube d square y by dx square minus 4x square into dy by dx plus 6xy is equal to 42 by x cube. First write the operator form. So x cube d square minus 4x square d plus 6x into y is equal to 42 by x cube. So now observing here, but x power d power not same, but x cube d square. So 1 x power is the greater than d power. So now eliminating x, and 1 x power is 1 decreasing. So how to decrease x power? Now dividing by x. Now dividing by x on both sides. that is equal to, dividing by x, equation 1, we are getting x square d square minus 4xd plus 6 into y is equal to 42 by x power 4. This is a now Cauchy-Euler equation. Substituting same, x is equal to e power z, z is equal to log x. Then we have xd is equal to theta, x square d square is equal to theta into theta minus 1. Substituting in equation 2, from equation 2, so that is equal to theta square minus 5 theta plus 6 into y. So that is 42 by e power 4z, that is a 42 into e power minus 4z. This is f of theta into y is equal to q of z. So that is equal to here. Now finding the complementary function, take the auxiliary equation, m square minus 5m plus 6 is equal to 0. The roots are 2, 3. 2, 3 is yc is equal to c1 into e power 2z plus c2 into e power 3z. If yp is equal to 1 by f of theta into q of z, that is 1 by theta square minus 5 theta plus 6 into 42 e power minus 4z. 42 is a constant, so which form here? E power ax form gada, ante type 1. Theta place lo minus 4. Take the factorization, so that is equal to 42 into 1 by minus 4 minus 2 into minus 4 minus 3 into e power minus 4z. So that is equal to e power minus 4z. The 42 is a cancel. So therefore solution is yc plus yp. So after replacing z, e power z by x, log, z is equal to log x. That is equal to final solution c1 x square plus c2 x cube plus x power minus 4. This is a solution. See the next example. So y double dash plus 1 by x into y dash plus 1 by x square y is equal to 1 by x square sine of log x square. That is equal, first write the operator form. So take the LCM, because there is no y double dash here, but there is no coefficient x square. Y dash means there is no x, but here y coefficient 1 by x square, and the 1 by x square must be eliminating. Now take the LCM, x square d square plus xd plus 1 is equal to, right outside x square sine of 2 log x. Okay, na? So this is a Cauchy-Euler equation. Substituting x is equal to e power z, z is equal to log x. Then we have xd is equal to theta, x square d square is equal to theta into theta minus 1. Substituting in equation 1. So that is equal to, simplification is theta square plus 1 into y is equal to sine 2z. The sine 2 log x here. The sine of 2 into log x is equal to z. The sine 2z. Which form here? F of theta into y is equal to q of z. So where f of theta is equal to t square plus 1 into q of z is equal to sine 2z. Take the auxiliary equation is m square plus 1 is equal to 0. Roots are m is equal to plus or minus I. Therefore yc is equal to c1 cos z plus c2 sin z. And a is equal to 0, b is equal to 1 gada. The variable z. Now finding the yp. Yp is equal to 1 by f of theta into q of z. So 1 by theta square plus 1 into sine of 2z. Which form here? 1 by f of d into sine bx form gada. Type 2. Where b is equal to 2. The theta square plus lo minus b square and minus 2 square replacing. That is 1 by minus 2 square plus 1 into sine 2z. That is equal to minus 1 by 3 into sine 2z. This is the yp. Therefore general solution of equation 1 is yc plus yp. Adding both, this is the result. In this substituting c1 into cos z, z is equal to log x plus c2 into sine of log x minus 1 by 3 into sine 2z means sine 2 log x. So this is the final solution of the given equation. Yeah, thank you. This is the Cauchy-Euler differential equation. For more videos, please do subscribe my channel, like and share it. Thank you.